Hello everybody, my name is Rafael Barba, and today we're going to discuss the conic sections, which are the circle, the ellipse, the parabola, and the hyperbola. They're called conic sections because they can be formed by intersecting a cone with a plane. So, for example, if we intersect this cone in this manner, we're going to form a shape right here, and that shape is going to be a circle. The ellipse is going to be the same thing. We can also intersect this cone with a plane like this. When we do that, we're going to form another shape, which is the ellipse. For the parabola, the same thing. When we intersect it like this, we form a shape. If we turn it around, you can visualize the shape being something like this. Something like that is going to be the shape. And for the hyperbola, you intersect it's going to be in the hyperbola. You're going to have to connect two cones, the two vertices, and you're going to connect. You're going to dissect it in this manner. And when you dissect it like that, you're going to form a shape that's going to be something similar to this. And that's going to be pretty much the sections that we're going to discuss.
Hello everyone, today we're going to go over the conic section on the circles. The circles derive from the Greek meaning hoop and ring. And the definition is, in the conic section, will be, as a conic section, the circle is the intersection of a plane perpendicular to the cone's axis. So as we can see here, we have conic section is about two double cones, right, intersected by a plane perpendicular to its x-axis. So as we can see here, we have two cones, and this is the intersection across the x-axis, and it will form a circle. And after we form a circle, there's a formula, an equation, which is x squared plus y squared square. This is the meaning of this. Will indicate you that the center of the circle will be at the origin, and then if the circle is not at the center of the origin, there's another equation that you can use, which is x minus h squared plus y minus k squared equals r squared. So if you use this equation, h and k will be the center point of the circle, and after so this will tell us the center, and this the r square will tell you the distance of how big the circle will be. So if you look on top of the circle here, and if we put it like on the graph, and let's say it's at the center is at the origin, and we have a circle, and for example here we can say the center is right here, right? And the R will tell us how far to go. And That will give you the distance of the circle. And that's pretty much it.
So the next section that we're going to talk about will be parabola. As I mentioned before, when you intersect the cone, you can also form a parabola. And first, let me start from the beginning. Well, when you hear the word parabola, the first thing that should come to mind should be quadratic function. And the definition of the parabola is a systematical open plane curve formed by the intersection of a cone with a plane parallel to its side. The path of projectile under the influence of gravity ideally follows the curve of this shape. That's pretty much the same thing that I explained a couple of minutes ago, but with more sophisticated terms. And so let me give you a little bit of background of the parabola. The name parabola is derived from the new Latin term, which means something similar to balance or compare. Once I explain the terminology and the main points, you're gonna understand why it's derived from balance or compare. So let's go to that part. So the first points that you're gonna have are gonna be the focus and the directrix. The focus, as you can see right here, is that point right there, and the directrix is the line right here at the bottom. So in the middle of that point, you're gonna have the vertex, which is right there. And we also need to have the axis of symmetry, and the curve that you see right here is formed by the x and y coordinates. Something very, very important to know is that the distance from the focus to the vertex is the same distance from the vertex to the directrix. And let's say that it's A. That's why let's pretend that it's going to be A. So I wrote A and A, same distance. So the distance from the focus to the directrix is going to be 2A. Another important part of the parabola would be the latus rectum, which is the line that intersects the focus and the axis of symmetry. It's a line parallel to the axis of symmetry. One thing, in this image, we see a parabola that's facing up, but that's not the only way that we can draw parabolas. They can also be facing down, facing to the left, or facing to the right. So the parabola that we saw over there, that one's very similar to the form y equals x squared. Since it's y equals x squared and you're squaring x, when you square x, it's going to be a parabola that's going to be either going up or going down. In this case, it's going to be going up because you are working with a positive x. I'll explain I'll explain how it can go into a negative in a little bit more. So when it's y equals negative x squared, it would go a parabola that would be to the opposite direction, which would be down. Now, I mentioned previously that it could also go sideways from one side or to the other side. So let's pretend that we have x equals y squared. Now this time you're squaring y. You're squaring y, so since you're squaring y, it's going to be something like this. And once again, it's positive. It's facing to the positive side because y is positive. If it would have been negative, such as in this case, negative y squared, then we would have a parabola that would go this way. So the general form of a parabola equation would be y equals ax squared plus bx plus c. And that would be in the case that it opens up or down. So it would be up or down, depending this is the part that I was going to explain, that I mentioned that I was going to explain. When A is positive, then it will be up. When A is negative, it will go down. So now, if we have x is equal to a y squared plus b y plus c, then we would have a parabola that would either go to this side or to this side, depending on whether A is negative or A is positive. If it's negative, it would go, it would open towards the negative side. If it's positive, such as in this case, it would open to the positive side. And now that is the general form of the parabola. That's the general form. Now let's talk about the vertex form. The vertex form would be y equals a of x minus h squared plus k, or x equals a of y minus k squared plus h. Once again, this one would be either up or down, a parabola that would be either up, or a parabola that would be down. This one would be a parabola that would be opening to the left or opening to the right. And okay, one very, very important thing to remember and to keep in mind is that h always goes with x. Always, always, h goes with x. And k always goes with y. So when you're working with k, with y being squared, you're going to work with k. Remember that when you're working with x being squared, h is going to be the one that you're going to use. And another thing, when you're squaring x, as in here, it's going to go up or down. When you're squaring y, as in here and here, it's going to be sideways or to the other side. So the equation that we're going to be working with is going to be the vertex form equation of the parabola. So, as I mentioned, it's going to be y equals a x minus h squared plus k. The first thing that we need to understand is that from this equation right here, we can easily derive, well, we can say that it's hiding in here, which is the vertex. The vertex, and the vertex is going to be h and k. Because h would be with the x coordinate and k would be with the y coordinate. So h and k. In this case, we're going to pretend that this graph is intersecting at the origin. So the vertex is going to be hk. And from this part right here, we can derive the axis of symmetry. Like I said before, we're gonna pretend that this is gonna be a parabola that's gonna be with a vertex at 0, 0. So it's gonna be 0, 0. And we're gonna derive the axis of symmetry from this part. So when we derive the axis of symmetry from this part, it's going to be x minus 0 equals to 0. So since it's x minus 0 equals to 0, what does x have to be to set it equal to 0? X has to be equal to 0. So our axis of symmetry will be equal to x equals 0. So let's start sketching this graph so that we can start drawing it a little bit more precisely. This is going to be our y-axis, and this is going to be our x-axis. So from here, we already mentioned that the vertex is going to be 0, 0, and that the axis of symmetry is going to be x equals 0, and this is x equals 0. So we're not going to move our parabola at all from the vertex, from the origin. So it's going to open. Okay, so before I draw it like that, we are squaring x, and a is positive. So since we're squaring x, it's going to be either to the top or to the bottom, opening to the top or opening to the bottom. But since it's positive, we're gonna do it opening to the top. So now let's look for the focus. Let's find the focus. The focus is gonna be, the focus is always gonna be inside the parabola. So we know that the focus is gonna be somewhere in here. A very good way to remember that the focus always goes inside the parabola is, you can think of the focus as a planet, and you can think of the curve, the parabola, as an object. Like when an object passes by Earth, and if the object's going really fast, if the object is not going at a very fast pace, then when the object passes through the planet, it's going to catch it on orbit, and it's going to go around and around and around and around. But if the object's going very fast, it's going to come in, and then what the planet's going to do, it's going to just swing it, and it's going to go back like a parabola. It's going to swing it. So you can think of the focus as the planet, and we know that the focus is going to be inside the parabola. So one thing, we know that this is H and this is K. This is H and this is K. So what is it that we're going to change in here? H or K? It's obviously going to be K, because we're going to stay on H. We're going to stay in the same coordinate for the x-axis is going to stay, because K is the one that we're going to change for the focus. So if this is I'm sorry, this is not HK. This is HK. HK. So since this is HK, we're going to stay with H, and we have to add something to K. Something has to be added to K. So for the axis of symmetry, no, not the axis of symmetry, for the focus, this is gonna be what we're gonna do for the focus. For the focus, we're gonna have H and K plus 1 over 4A. The A, we're gonna get it from here. So 1 over 4, that's going to be constant. That's going to be always the way that you're gonna solve for the focus. So in this case, the distance from here to here is going to be 1 over 4a, because the distance from here to here is going to be 1 over 4a. So it's going to be k plus 1 over 4a, and it's going to give you the focus. Now to find the directrix, as I mentioned previously, the distance from the focus to the vertex is going to be the same distance from the vertex to the directrix. So this is going to be negative 1 over 4a. So for the directrix, we're gonna have H again, because we're not doing anything to the H. The x-axis is gonna stay, the x coordinate is gonna stay where it is, and it's gonna be K. Since we did plus over here, it's gonna be minus 1 over 4A. So now we have the directrix, the focus, and the axis of symmetry.